So we are going over a general overview of kind of what this next unit is looking like. We are getting into Trig, which is absolutely my favorite. And the reason that this is important is because all the things that you are doing now is literally the basis for everything you will do in pre-calculus and calculus moving forward. So here's where we kind of start to get into big math. Very first thing that we want to go over are some things that you've already seen before. You've already seen a coordinate plane. So we know that there is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We know the value of x and y in quadrant 1 is both positive. We know that in quadrant 2 that your x is negative, your y is positive. We know that in quadrant 3 both x and y's are negative, and we know that in quadrant 4 your x is positive and your y is negative. Now you also know that when you're talking about a unit, you're talking about 1. So a unit circle is something that you're going to start hearing a lot of, and a unit circle is essentially a circle that has a radius of 1. Its origin is at 0, 0. Let's see if I did this guy right. Needs to be a little larger. So its origin is at 0, 0, and the radius of this circle is 1. If I do a little bit of a zoom in, here's what I'm looking at. I know that here is my circle. I know that my radius is 1. Now let's talk about a few things that we know that are true in a circle. We know that a circle has 360 degrees. And then I also know that a right angle is 90. So when I'm looking specifically at my unit circle, I can start filling out a few things here. I know that I'm starting at 0, a right angle is 90, 90 more degrees is 180, 90 more degrees is 270, and 90 more degrees gets us all the way around to 360. And this pattern just keeps on repeating itself, repeating itself. The other thing you need to know is that when I go and do my degrees in a circle, it goes counterclockwise, and the reason why is because we are always going through our quadrants in order. So we start in quadrant 1, we come here, quadrant 2, quadrant 3, quadrant 4. Knowing that, we've already seen that we can kind of break this up. So I know that between 0 and 90, halfway is 45. Halfway between 90 and 180 is 135. Halfway between 180 and 270 is 225, etc., etc. So we start breaking this up to get a little bit more specific. Now in the Do Now, I ask you guys to Google, or in the exploration, I ask you guys to Google and find some screenshots of reference triangles. And you're probably thinking, like, why in the world did I do that? Well, you probably came up with something that looks like this. When we see these reference triangles are what you guys did in Math 2, and it was essentially how can I fill out the side links very quickly without having to do much work. Now, when I'm using reference triangles in the unit circle, we are going to use these. What I want for you to know is that we have a few of those reference triangles. Here's my 45, 45. And what these guys do is your reference triangles should fit pretty nicely into your angles. So for example, here's my 45, 45. It's just a little bit scaled down. And you see that he fits right here. When I look at my 30, 60, 90 triangle, I also see that it fits right here in my circle. And that also if I manipulate it, so if I flip it around, you should see that it also matches. So that 60-degree side, when I rotate this guy, should match that 60-degree angle. How all of this starts coming together is that you know that your unit circle means the radius is 1. That means for every single one of these triangles, when I'm plugging them in here, my hypotenuse is going to be 1. Because that radius swings around and is the hypotenuse for every single one of these triangles. So every single one of these radii is going to be 1. When I'm given my reference triangles, I notice that my hypotenuse is not 1. So it just takes a little bit of quick math to start reorganizing this. You know that if the square root of 2x needs to equal 1, I can solve for my side lengths pretty quickly. Divide by the square root of 2, and then rationalize the denominator by multiplying by root 2 over 2. When I do that, I get that each of these side lengths, so if my hypotenuse is 1, each of these side lengths are now going to be root 2 over 2. Same thing going on here. I know that if my hypotenuse is 1, that means that my short side length is actually going to be 1/2. And my long side length is going to be the square root of 3 times that. So it's going to be square root of 3 times 1/2, which is the square root of 3 over 2. So I start making some connections here between all of this. For the purpose of this unit, what we're going to be using now on when we talk about reference triangles is we're going to be using these two guys right here. So when we talk about our special right triangles, our 30, 60, 90, our 45, 45, 90, instead of using your Math 2 or your Math 1 ratios or proportions, we're now going to start using our pre-calc ratios and proportions here. The last thing that's going to be important moving forward in this unit is the ability to use a calculator. You guys do have a calculator called Wabbit Emu. If you search in that search bar, W-A-B-B, Emu, it should pop up as the calculator that is in your or on your desktop, and it should look very similar to the calculators you get to use in your class. Now let's talk about a few things really quick and just make a few connections. I know that sine is going to be opposite over hypotenuse. You remember those SOHCAHTOAs. So when I do sine of 30, you get 0.5, opposite over hypotenuse, which when I go across or opposite of 30, I get 1/2. When I do cosine of 30, I get 0.86. Now I know that cosine is adjacent over hypotenuse. Since my adjacent side is square root 3 over 2, let's just check something and see if it works. Square root 3 divided by 2. I also get that same value. Now this is just something to kind of keep in mind as we go through this. We're going to start making many more connections the further we go through the unit. But for this sake forward, remember they're 360 degrees, and your reference triangles, when we talk about those, we're going to be talking about these two guys right here moving forward. If you guys have questions about this unit, please don't hesitate to reach out to your teacher. I'm so excited for us to go through Trig together.